the development framework that we have developed at CATEC, the research center I work for. We started with this framework like 4 years ago, and we have been using it for our UAV projects for 2 years and a half. So, well, this is not just my work, but also the work of all my colleagues. So the main names are shown there. So just let me say that when I'm talking about the framework, I'm talking mainly about 3 components that are an autopilot, a payload manager, and also a ground control station, and all the development, let's say, methodology that are involved in developing unmanned systems. So let me start with the motivation, a little motivation. So why did we start with this developing this system? So we as a research center have different research topics. One of them is our GNC algorithms. So we need an autopilot, an open autopilot, where we can just modify the algorithms and have full control of all the things that happens or that are processed within an autopilot. So that's why we needed an autopilot with these characteristics. We also work with different types of sensors. So we have multispectral cameras, LiDARs, sonars, and infrared cameras, of course. So we need also a payload manager that can deal with all those kinds of different sensors. And we also make projects with different types of aircrafts. So we have from quadrotors, we have also fixed wings from this size to 6 meters of wingspan. We also have helicopters that are also with different sizes, even this big. So we don't really need we don't want to have one different development frameworks for each of them, but just one unique development framework for all of them, so we can easily change from one to another. And that's the motivation why we started with this. So let me just continue with the system architecture. So those are the components, the main components of the system. So as I've told you, it's well, we have the autopilot that is in charge of getting the sensor data, the navigation sensor data, and processing them for control, and you all know. And then we have the payload manager. This is basically an onboard PC that is in charge of controlling the acquisition of the data and processing them. And you can select, for example, to log them, to stream them, or whatever. They are both, the autopilot and the payload manager, connected by a link. So the payload manager can get the positioning attitude data for the aircraft and just tag the data from the sensors, from the payload sensors, for post-processing or whatever. So, and then in the ground part, we have the ground control station system. Here I've just divided the software in 2 parts. The part that is the ground control station itself is the traditional ground control station functionalities. And then we have the payload ground software that is in charge of where you can visualize the data you're receiving from the onboard sensors. And you can also command the sensor. So you can, for example, select when to start the acquisition, when to stop it, if you want to get the streaming or not, and so on. So it's basically the architecture. This is how our autopilot looks like. This was the older version. This is the new one. Well, this is one of the fixed-wing UAVs we have developed at CATEC. So to start with the first component, it's well, the autopilot. So our autopilot has been made by us, both the hardware and the software. So in the hardware part, we have 2 boards. The main one, or well, the one that works, that has the control of the system when everything's fine and not in fail-safe mode, is called the control board. It is based on the BeagleBone board, so you all know it. And then we have a safety board that has been built by us. And the safety board is in charge of getting the readings from the sensors and also communicate with the servos and the RC link. So the control board, as I said, has the full operational GNC algorithms, and also, well, it's the one that normally works when there is no problem with the system. So it uses we use QNX operating system, which is a real-time operating system. It's used by, I mean, it's certified, so companies use it. It's not like VxWorks, because that's much more expensive than this one, but it's also certified, so yeah, it's pretty good. Actually, if you are an academic entity, you can get a free full license. So if you are interested, you can ask them. And then on the safety board, we use a microkernel. It's free RTOs. This one is open source. So the idea is that if a failure happens, the safety board takes control of the system, but it includes just a safety mode GNC algorithm. So it just will manage to make a return to home mission, or if you lost GPS and you cannot navigate, you can maybe, if you have a fixed wing, you can loiter, or if it's a multi-rotor or rotorcraft, you can hover, something like that. So yeah, let's continue with the next one. So this is our ground control station. Just let me play a video. I haven't embedded in the presentation because it's quite large. So let's see if it works here. Oh, and let me just turn this off. Okay, so yes, go around. So this is how it looks like. We have developed it from scratch using C++ and with Qt framework that probably you know. So yeah, it has the traditional ground control station functionalities. So have a horizontal, artificial horizon. Here the red point, it's like the home point. So it's where the safety pilot is. You have this red circle that just indicates you the line of sight range. And you can just, for example, this purple point, it's a loitering point. So for fixed wing, you just in real time select a point for the aircraft to loiter. And the thing is that we have developed it in like a plugin-based application. So you can just load new plugins and add it if you need it. For example, we created this plugin that is for showing the telemetry in a Simulink-like appearance. And we also integrate the payload control software into this application. So you can have a plugin we have a plugin actually for infrared payload sensor, so you can visualize the infrared data while you are developing the mission. And yeah, that's basically it. So let's continue. So I'm sure I'm not running out of time. And so let's continue with the Payload Manager. The Payload Manager is just a computer. It's an Intel Atom computer. And that's how it looks like. We use like, this kind of connector, so to be sure that it won't unplug with the vibration of like big rotorcraft. It's to have a USB can be tricky. So it's really a USB port, but it's not the typical connector. So related to the architecture, we have used ROS, their robotic operating system, for this for the development. So it's quite modular. You just have ROS modules, and you use the ROS middleware communication protocol for communication between them. It's a publish subscribe paradigm. So here, for example, in this case, we have a IR camera module, visual camera, and then we have a logger module that is in charge of logging all the sensor data, a streamer that is in charge to send it to the module that is on the ground control station, that is the blue one, and there is another one in charge of the communications. So that's basically the thing. Okay, so yeah, just let me continue with some applications where we have used these elements. So the first one is called, it's a FP7 project from the European Commission that is called Philcopter, devoted to precision agriculture applications. This is one of the helicopters that we have that is actually from Flyincan. It's a manufacturer from Belgium. They actually won an Oscar for this. And here we just put an infrared camera on board, and we use our Payload Manager that you can see on the image just beside the camera. And we use also the payload control software on the ground control station. So in this case, we didn't use the Autopilot because they have their own one. And yeah, the ground control station was just a part for the payload sensors. Well, let me just continue with this other project. I have a video for this one, so just let me check. This is it's a thermoflight project. It's for wind blade thermography inspection. And yeah, we use basically in this case the same platform. So let me check, it's 25. It's a bit long video, so yes. Okay, see it just like that. So yeah, here we use basically the same stuff. So the infrared camera on board and the payload manager just to control acquisition of the camera, and yeah, it's basically just go up and down to inspect the blade. And then, yeah, I just wanted to illustrate this case. So let's continue. Okay, I have another video for this. Sorry because about this, but so in this case it's also an FP7 project that we are leading. It's called ARCAS. We are actually pretty proud of it, I have to say. And in this case, it's devoted to aerial robotics manipulation. So in this specific task, we developed that quadrotor with an onboard robotic arm. So this is a Vicon system that we have there at Catec too. And that is that the quadrotor has to grab the bars and build an assembly. This is completely autonomous from taking off to landing, and yes, kind of. We have now a new version because this robotic arm just had 2 or 3 degrees of freedom. I don't remember. So now we have a 6 degree of freedom arm. So it's more like a human arm. So, and now at the end you'll see it on fast motion, just to see that it was done just on one trial, not. Actually, we have done this experiment many times because each time we have a visit there at Catec, it's kind of the main attraction. So it's pretty well debugged, so it works. And that was it. And just to finish, as we are in a aerial robotics competition, I wanted to also to mention that we think that our system can be used for this type of competition, of contest. So I just want to mention about the Eurathlon project that is also an FP7 project, and it started to organize a multi-domain robots competition for disaster relief scenarios. So the idea is that ground, aerial, and underwater robots will have to collaborate to accomplish some disaster relief tasks. So it will be held next year in September in Tuscany, Piombino. So that would be like the location of the event. And yeah, this just to mention some of the drafts of the scenario. So there will be some missing workers that have to be located. There will be a reactor building that has to be inspected. So maybe there are obstacles to the entrance. So maybe the UAV can fly and make a map and just tell the unmanned ground vehicle about the obstacles so he can enter the building. And there will also be some leaking pipes that had to be detected, and some stopcocks that has to be just closed. So the valves have to be closed and the leak just controlled. And just to conclude, the conclusions are just, it's more a summary than a conclusion. So yeah, we have been using this flexible framework for a long time, for 2 years and a half more or less, and we have used it in many projects, not only those that I've presented here, but also some more. And it's pretty flexible in the way that it's easily adapted to be used in other projects and other platforms. And yeah, we have the Autopilot, the ground control station, the Payload Manager, and yeah, that's basically it. So thank you very much for your attention, and if you have questions.
Pre-read through the paper and have one from your presentation. So for your, in how you do your flexible framework and architecture, do you have a specific way you're doing error handling, or, and also how did you select the standards for the interfaces?
Okay, so the question is if we have error handling mechanisms. That was the first question. The answer is yes. We have, for example, all the drivers of the sensors monitors the state of the sensor, because they usually give you that signal, and they have a heartbeat signal. So there is a module that just keeps monitoring the heartbeat, and if something goes wrong, it just we have a state machine with different modes, including fail-safe, and it just switches the mode from one to another. And related to the second question was that how we selected the interfaces. Related to with respect with the payload sensors, it was just based on our experience, because we have been working with this before developing this. So yeah, we sometimes that was part of the motivation, actually, that we sometimes find it hard to how to connect this without putting external elements like switches and so on. So yeah, we try to put like the typical interfaces that were required, and also to make it expandable, like with some expansion slots and that stuff, so you can add more. And yeah, basically that's the way we. Okay. Yeah.
Does your Payload Manager talk to your Autopilot in any way?
Yes. Well, the question is if our Payload Manager to our Autopilot. It really just get the information. So it won't command it in any way. Just the information for tagging the data. That's basically what it does.